Hi, I'm Sean Keef. I'm a security engineer with Skybox Security, and I'll be demonstrating the Skybox Security Suite for you today. In this video demonstration, we will explore how Skybox can be used to help organizations reduce access of overly permissive rules. We'll do this by using our unique what-if workspace combined with network path analysis. In this product demonstration, we'll explore the concept of adding risk awareness to the change management process. We'll start by looking at Skybox's ability to track observed changes on firewalls. As firewall configurations are retrieved, they're compared to the prior configuration that was retrieved, and changes are pulled out and delineated. If I look in our change tracking section, I can see some changes that have occurred on a Palo Alto firewall in our demo model. So here I can see that there's a specific entity that was changed, application group members. I can see what the change looked like before and what it looks like after. I can see that after the change, a new object was added, or a new application was added, called flash get. We can also show new objects being added, new rules being added. Any changes that occur are delineated and tracked in our observed changes section. For the next part of the demo, we want to take a look at the change manager interface through a web browser. This is our change manager interface. We'll start by looking at a change that I recently created. When a change request is made, it's done so by defining the source and destination by using IP addresses or ranges or networks, as well as the service that is needed between the source and destination. So down here under change request, I have the original request that I've made. Typically, a user will create this, and then when they submit it, they're essentially promoting it to the next phase. Normally, each phase would be owned and viewed by different people on the network. As an administrator, I'm going to be able to see all of the different phases, but you can imagine that these would be looked at by different people in a normal scenario. So the second phase of our process brings us to technical details. Typically, this is where a network administrator would look at that original change request and translate that into specific changes that need to be made on individual firewalls. These individual changes are called derived change requests. What has occurred in the background is a web services request was sent from our change manager interface to the analysis engine, and the analysis engine returned 3 firewalls that were in the path and which ones need to be changed or don't need to be changed to allow that access to take place. On the right-hand side here, I see that one of those changes is unnecessary, that access already exists on that firewall. So a network administrator could make other modifications here. They could decide that they want to make this derived change based on creating a new rule. Right now the system is recommending that we just modify existing rules. The administrator may also decide to make that change by modifying an object. So he has the ability to specify exactly what should happen to allow this change to take place. From here, the change request is going to go to risk assessment. So it will be promoted and then it would go to the person in the company who is responsible for making a decision about this request based on what kind of risk this change would impose on the network. If you remember from before, the whole idea behind adding risk awareness to the change management process is to keep our network in compliance all the time. So up here at the top, I have the individual derived changes that we saw from the last screen. On the right-hand side, I have some red X's and green checks around whether or not that derived change would cause a problem with compliance or security. And I can see my top one here has red X's on both of those. If I click that, down below I get a description of the policies that would be violated if I allowed this change to go through, as well as the vulnerabilities that would be exposed. Part of looking at the risk that a vulnerability imposes is understanding what kind of exposure a vulnerability has. If a vulnerability is only exposed to one segment of the network, and then it's exposed to another segment of the network, that increases the amount of risk that that vulnerability will impose on the network. So this is a very important feature, and it's one that's missing in all other change management platforms. The ability to see not only policy violations, but vulnerability exposure as well. It's a feature that's unique to our product. Once vulnerability has been assessed, the ticket can then be rejected, returned back to the owner, or it can be promoted. In this case, since there are risks associated with the ticket, the person doing the risk assessment might want to make some notes down below and make some kind of a risk assessment as to what level of risk this change would cause. Once it's promoted to the next level, it would go to implementation details. This is where a network administrator would then look at the final changes and actually implement those on the network. I have 3 tickets that are sitting in that stage right now. Ticket 342, 343, and 344. Just kind of look at those for a second. We can see this particular ticket, the title is 10 IPs HTTP to DMZ. So I can see that there's a range of IP addresses. The request is being made to allow those IP addresses to talk to an entire Class C network over port 80. So you'll want to remember these 3 tickets, as we'll use them in just a second when we look at change reconciliation. So back in Firewall Assurance, at the bottom of our summary screen, we have change reconciliation. This is a screen where we can see how Firewall Assurance has matched up observed changes with approved tickets. So we can start off looking at this first one. So this is change 507. It happened on our VLab picks. If I look at change reconciliation, I can see that this observed change was matched up to ticket 342, which is titled SSH to Intranet Server. We can see here a description of the ticket coverage and the change coverage. The ticket coverage describes how much the ticket is covered by the change. The change coverage is the reverse of that. How well is the change covered by the ticket? In this case, we can see both of those are 100%. This tells us that there's an exact one-to-one relationship between the description of the ticket and the change that was observed on the network. Let's look at something a little more complicated. Change number 506 on the VLab picks matches up with that ticket that we looked at earlier, ticket 344, which is titled 10 IPs HTTP to DMZ. In this particular case, I can see that the ticket is only covered 10% by the change. The change, however, is covered 100% by the ticket. Let's look at why. If you remember in the ticket described a range of 10 IP addresses that should have been allowed to access that Class C network. If I look at the details for the change, down under source, I can see that only one IP address was actually allowed to have that access. So the observed change was only for one IP address going to that class C for HTTP access. So you can see now how the ticket coverage makes sense at 10%. Essentially what we're saying is that the ticket has only been implemented 10%. Additional access would need to happen to allow that ticket to be fully implemented. The other side of the coin is looking at the change. In this case, we see that the change is covered at 100%. The IP address that was allowed in that observed change was completely covered by the ticket. So we know that the change is authorized, but the ticket has not yet been fully implemented. We can also look at the reverse of that. In change number 505, we see that it was reconciled to ticket number 343. Ticket 343 describes two IPs having HTTP access to the DMZ. In this case, I have the reverse. The ticket is covered 100%, but the change is only covered 1%. So our ticket describes two IP addresses that were to be allowed to access the DMZ. If I look at my change details, I can see the network administrator has actually allowed an entire Class C address to access my DMZ. This is an overstepping of the bounds of that ticket. It's allowing additional access than what was actually described in the ticket. So in this particular case, what would happen is the change would sit in a pending state for a certain number of user configurable days. The idea here is that maybe the administrator understood that in reality there would be more people that needed access, and two IPs weren't really the number that should have been accessed. And so he created the change that allowed the entire Class C. And maybe he went in after the fact and created a ticket to describe the change that he just made. As that ticket goes through the process, it would come in after the change was made. So we actually have the ability to reconcile changes to tickets that were created either before or after that change. So in summary, we can see the power that exists in integrating risk awareness into a change management process. The reconciliation process also allows administrators to close the loop and make sure that everybody in the network administration staff is following the process for change reconciliation. This also provides us a verifiable audit trail around these changes, so we know who made the changes and when they were made and whether or not they were authorized.